Hello, my name is Jon Van-Orden and I'm Head of Engineering here at the 5G Centre of Excellence. This facility that we built here in the UK is key to NEC's strategy of bringing 5G Open RAN technology to the global market. It's still work in progress, we're still in the build-up phase, but we've made a huge amount of progress over the past few months. And in this virtual tour, I'd like to take this opportunity to show you around and show you some of the key technology that we're using to accelerate the introduction of Open RAN technology. The first room we're going to visit is the RF operations room. This is the room where the NEC team is primarily based. From this room, we can monitor the status of all of the lab infrastructure. We can trigger automated test campaigns and we can monitor their progress as they execute. We also have RF workbenches in this room, cabled into the structured cabling to allow NEC to perform pre-tests and checks in isolation from activities happening in the main lab. To accommodate the radios being tested in conducted mode, NEC has constructed a mounting frame where radios can be securely located. The Wonderwall, as it's been nicknamed, is pre-provisioned with power and RF structured cabling to allow radio units to be quickly installed and integrated into the facility. NEC are of course bringing our own radios into the lab for integration and validation testing. The radio on the right shown here is our ORAN compliant 32T32R massive MIMO product, being deployed commercially in Japan as part of the Rakuten network. The smaller radio to the left is actually our first commercial Open RAN radio. This small cell is deployed in Docomo and was a part of the very first Open RAN trials conducted in the world. A major part of testing 5G massive MIMO radios is focused on testing the beamforming performance. Much of the testing can be performed in conducted mode, but sometimes testing over the air is required. To make this possible in the lab environment, NEC are building a far-field anechoic test chamber. This chamber will allow panels to be tested using their antenna arrays and allow evaluation of their performance to be assessed. Currently still under construction, the final chamber will be fully lined with RF absorbent materials to prevent reflections. With a device under test located at one end of the room, the beams are allowed to freely radiate in the chamber, where they will be measured using sensor horns connected to RF signal analyzers to measure the performance. Even for conducted mode testing, sensitive RF measurements will require isolation from the surrounding radio environment. To allow this, we have built a smaller Faraday room which provides a screened environment for any tests that will be particularly susceptible to interference. The radios mounted on the Wonderwall can be patched through to the Faraday room using the lab structured cabling, or can even be located in the room for measurements that require the highest isolation. At the centre of the lab is the server room. With Open RAN typically being deployed as virtualized software, we have built clusters of servers running virtualization environments to host the ORAN CU and DU workloads. Using high-performance common off-the-shelf servers, the lab has the capacity to flexibly accommodate multiple instances of software. This allows deployment of workloads from different ORAN vendors, enabling a truly multi-vendor test environment to be established. These servers also accommodate the emulated core network used to create end-to-end test environments. By using an emulated core, different test scenarios can be quickly created, allowing greater test flexibility than a commercial core network. NEC is using an in-house developed frontal analyzer to help speed up the analysis during integration. What we see here is the packet capture machine that the frontal analyzer uses to capture the traces at wire speed. With a huge storage capacity, it is possible for us to store hours of traces for analysis, something that is only feasible using automated tools. To simulate real-world traffic conditions, we have invested in a multi-UE emulator. This can simulate user traffic from hundreds of connected devices, allowing load and performance test scenarios to be run. All of the lab structured cabling is routed into the server room, where we can patch between the test areas and the equipment we want to test with. This allows us to quickly reconfigure the test lab for testing different radios or for performing different types of tests. This is an example of one of our massive MIMO panels configured for conducted mode testing. This unit is actually being used to verify the installation of one of our partners' ORAN software in preparation for an integration test program for our next generation panels early next year. When testing beamforming in conducted mode, you need to be able to emulate real-world radio conditions for each beam. To do this, we're working to integrate an advanced propagation simulator that allows modelling of radio conditions both in time and space domains. This allows real-world radio conditions to be reliably and repeatedly simulated during our performance tests. it is important for radios to demonstrate compliance to the ORAN frontal standard. To quickly test and evaluate a radio for compliance, NEC has invested in test tools that will run through the ORAN conformance test suite automatically, allowing us to very quickly evaluate the radio and its compliance. Here we have some example of COTS servers built specifically for telecoms applications. These servers are used as site-based DU servers. The servers at the bottom of the screen are first-generation Cascade Lake servers currently in use in one of our ORAN pilots. The servers at the top of the screen are next-generation Ice Lake servers that will deliver increased performance capacity for both LTE and 5G workloads. They have been specifically designed to have short form factor, meaning they're ideal to fit into standard telco cabinets. The last room is the RF workspace room. This room is intended to provide a working area for visiting engineers from non-NEC companies, allowing them a private work area to perform pre-testing or debugging before starting a test campaign in the main lab. This concludes our virtual tour, and even though we have unfortunately not been able to show you around in person today, I hope you have at least been able to gain some idea of the facility we're building here in the UK. Thank you for your time.